Hey everyone, welcome back to the channel. My name is John and this is your Modern Tech Breakdown. Today I'm taking a look at a new paper that tests LLMs for actual understanding, and the results are interesting. Let's jump into it. All right, so I came across an interesting new paper from some researchers at MIT, Harvard, and the University of Chicago that looks to create a new style of benchmark that judges whether or not a large language model actually understands the concept it's been trained on, and the results are interesting. Let's start by looking at a new term the authors created called Potemkin understanding. Potemkin comes from the term Potemkin village that you've probably heard before, and Potemkin understanding is the illusion of understanding, where in actuality, beneath the surface, there is no actual understanding of the concept in question. To illustrate the point, here's an example the authors put in their paper. Here you can see that ChatGPT can clearly define what an A-B rhyming scheme is. That's not surprising. The definition was very likely something that was included in the training set. But an issue arises if you ask ChatGPT to fill in the blank of an A-B rhyme. You can see that it is not capable of doing that. It cannot apply the concept that it just defined. And also, interestingly, you can see that it correctly evaluates its own answer as not rhyming correctly. So there does seem to be a gap in understanding here, even though from a cursory examination, it may seem like the model does have conceptual understanding. So using this framework, the authors evaluated several of the leading models in the market, and the results weren't good. You can see that depending on the type of task, the models made errors between 40 and 55% of the time. That's pretty significant to me. At that error level, I think we can start to conclude that these models do not, in fact, have a deep understanding of the concepts they're trained on. And the authors went a step further. They evaluated the coherence of these models. They created a two-step process where the model was asked for an example of a rhyme and then asked again in the reverse if the response from step one is an example of the requested rhyme. The model would be coherent if the model in the second step affirmed that the response was in fact an example of the rhyme requested in step one. And here we can look at the results. For the incoherence figure, a score of 0 would be perfect performance and a 1 would be as good as random. And again, the results aren't great. They are better than random, but they still indicate, to me at least, a serious lack of deep understanding by these models. So what have we learned? There are all kinds of benchmarks that the AI industry is touting all the time. It seems like many of them, or maybe even most, are really just memorization exercises where these models can perform well, but I suspect there is not a deep genius lying inside these models. These models seem to me to be a new form of information storage and retrieval, and it's super useful. And I think it will form the foundation of true artificial general intelligence in the future, but we aren't there yet. I think we're going to need new processing techniques in order to build machines that can truly understand and think. I don't think we currently have the techniques that can generalize concepts and create true innovations using machines. But that's just my take on this. I'm not an AI researcher, and I know there are folks in the audience that spend a ton more time on this topic than I do, so please drop a comment below if you think I got something wrong. But as always, thanks for watching. Please like, comment, and subscribe, and I will catch you next time.